Use the PES for the unknown elements PES. Identify the subshells responsible for the peaks at 0.63, 0.77, and 3.24. Now note, in this case, the energies increase going left to right. Identify the element. From which subshell would electrons be removed most easily? D. What would be the most common ionic charges for this element? And finally, why would a 4+ ion be highly unlikely for this element? Identify the types of subshells responsible for the peaks at 0.63 times 10 to the minus 19th joule, then 0.77 and 3.24. Well, we have 7 peaks, 2, 3, 4, 5, 6, 7. So here's our electron configuration. We write that out based on the number of electrons. At 0.63 over here, that is the 7th subshell with the least effective nuclear charge, so that will be your 4s. Even though the electron configuration shows a different order here, okay, we're going by binding energies now, not by the Aufbau diagrams. At 0.77, that is going to be your 6th subshell. It is the 3D as it requires more binding energy than the 4s, even though it gets filled after it. And you can also look at the relative height here of the peaks, right? The 4s2 has a peak twice as high as the 3d1, indicating 2 electrons versus 1. At 3.24, that's your 5th subshell, so that's going to be your 3p. And this time we count from right to left because we're going from smaller binding energies to higher binding energies. Identify the element. With an electron configuration of this, it has 21 electrons, an atomic number of 21, so the element is scandium. From which subshell would electrons be removed most easily? Well, electrons from the 4s subshell can be removed most easily, as subshells in the n equal 4 shell have the lowest binding energy. And in this case, the 4s2 are 0.63 times 10 to the minus 19th joules. It requires the least amount of energy to remove 4s electrons because they are the outermost electrons and experience the most shielding. What would be the most common ionic charges for this element? Well, 2+ and 3+ ions would be most likely. 2 electrons can be removed from the 4s subshell, resulting in a 2+ ion. 1 electron from the 3d orbital can then be removed to produce a 3+ ion, as the energy gap between the 4s and the 3d subshells is relatively small. Why would a 4+ ion be highly unlikely for this element? Well, a 4+ ion would not likely occur because the energy required to remove an electron from the full 3p subshell is much, much higher. After the first 3 electrons are removed, the resulting scandium 3+ has acquired a noble gas configuration of 3s2, 3p6, similar to that of argon, which is very stable. A much greater amount of energy would be required to remove another electron, to take an electron from the 3p6.